Hi there, welcome to this video 6-2. This is anti-differentiating or integrating exponentials and trig functions. Our objective for this is to be able to anti-differentiate or integrate exponential functions as well as trig functions. And now that we've already kind of talked about anti-differentiation being the inverse or the opposite of differentiation, you can kind of get the idea of when we look at derivatives and trigonometric functions, we're just going to be working backwards. We're doing the inverse of derivative rules that we already have. So just starting out with exponentials, looking here, the derivative of e to the x is e to the x. So what do you think the integral of e to the x is? E to the x. So it's no surprise here that the integral of e to the x dx is e to the power of x plus c. With a exponential of a different function, or sorry, of a different base, so the integral of a to the x dx, well, that's also going to be a to the power of x, but we also have to divide now by the natural log of whatever that base is. And the reason for that is if we were to differentiate a to the x, the derivative would be a to the x times the natural log of that or of that base. So we have to go ahead and undo that. Now, the rest of the derivative rules are the direct inverses of differentiating trig functions, and you'll see them here. I won't go ahead and just read them to you because they are the direct opposite, and I know that you can go ahead and read them. But what I want to go ahead and point out or highlight is this device that can help us remember the derivatives and antiderivatives of trig functions. And I showed you this when we talked about derivatives of trig functions, that if we move in a clockwise direction, if I go from sine and I take a derivative, I'm moving in a clockwise direction, and that's going to be cosine. And then the derivative of cosine is negative sine. And the easy way to remember this is that your north and south pole, those are y values. They're installing security cameras right now, so you hear drilling. If you move clockwise, that's going to give you the derivatives, okay? So y values at the north and south pole, that's sine. And then your x values are your, I guess, east and west poles, ends, if you will, okay? Now, in order to find the antiderivatives, if we move in a counterclockwise direction, if I'm taking the integral of cosine, that's going to give me sine. And the integral of sine is going to give me negative cosine. So you can just move in the opposite direction. And I have it right here, right behind me on the board, that same kind of mnemonic device, okay? So that can help you remember that. If you want to pause the video, go ahead and read this paragraph here. It just kind of highlights what I just said. Okay, so let's go ahead and look at some examples. So here are the examples, and we'll start out with number 1. And they want us to go ahead and integrate negative 3 sine of x dx. So I'm going to go ahead and just rewrite this. I'm going to pull out that constant. So I have negative 3 times the sine of x dx. And I want to go ahead and integrate sine of x. The integral of sine of x is negative cosine of x. And you can just kind of also always check yourself as well by asking yourself, what would be the derivative of negative cosine of x? Well, the derivative of cosine is negative sine. And that negative is going to cancel out, okay? Another way of thinking this too is you know that sine and cosine are connected. Whenever you integrate and your answer is going to be a you're going to have a negative, okay? Additionally too, this kind of device right here, right? If I'm at the North Pole up here and I go this direction, okay, I'm integrating, that is negative cosine. So that's another way to remember it. Okay, so I'll go ahead and distribute this out. The negatives cancel and we get 3 cosine of x plus c. There's our answer. Pretty straightforward, yeah? Yeah. All right, here's number 2. I have the integral of e to the x dx minus the integral of 2 to the x dx, right? I can just integrate each piece by itself. Hey, integral of e to the x, that one's really simple, e to the x, minus the integral of 2 to the power of x. Hey, that's the same thing, 2 to the power of x, but I also have to account for, if I was going to differentiate this, I'd have to multiply by the natural log of 2, so now I have to divide by the natural log of 2. Okay, and this is an indefinite integral, so we have to add on that constant that we would lose if we were taking derivative. Okay, moving right along. Ooh, now they're starting to get weird on us. Okay, the integral of the cubic root of t squared plus 3 cosine t minus 1. Not too complicated. They're just trying to kind of freak you out. I'm going to go ahead and I'm going to factor out a 5, pull out the 5, and this is just t to the power of 2/3 plus the integral, or 3 times the integral of cosine of t minus the integral of 1 dt. Sorry, all of these are dt. So I'll just throw this in here. Okay, and again, you don't have to write down every single integral and break it apart this time. This just is kind of the steps I want you to know what's going on. You can kind of do that mentally, if you will. So, okay, I have the integral of t to the power of 2/3 with respect to t. So I'm going to increase my power by 1, so that is t 3/3 plus 2/3 gives me 5/3. And I have this times 5, and then again I have to divide. This is the power rule. Divide by the new power, which is 5/3. I'll have to come back and kind of clean that up. Okay, 3 times the integral of cosine of t, that's just going to be sine of t. Okay, minus the integral of 1 dt. Well, the integral of 1, if you go from a linear, it's just going to be, or sorry, from a constant, if you integrate, that's going to be a linear, so I get minus t, right? Not plus x, because again, we're integrating with respect to t, okay? So there you have it. Oh, I do want to go ahead and clean this up. Here I have 5t to the power of 5/3 divided by 5/3, so I'm going to multiply by 3/5. And what ends up happening is my 5's cancel. So here is my final answer. So I have 3t to the 5/3 power plus 3 sine of t minus t plus c. Not too bad, not too bad. Okay. All right, last example before I go ahead and throw you a practice problem here. I want to integrate the secant of y, tan y divided by 4 with respect to y. So what I'm going to do is I'm going to pull out the 1/4. So I have the integral of secant y tan y with respect to y. And again, the easy way to think about this is, okay, the derivative of what gives me secant tangent? Well, that is just secant itself. So this is 1/4 secant of y plus c. There you go. Fourth example. Okay. Again, make sure you pause me if I'm going too fast. If you have any questions, write them down. You can ask me or another kind of instructor at a later date. But those are the 4 examples for trigs and exponential functions. And I do have a practice problem here for you, just kind of to see if you understand what's going on. So go ahead, pause the video, and then I'll post the answer here and we'll talk through the solution. All right, I'm going to go ahead and post the solution. We have the integral of 6 to the power of x minus 2 over x to the 4th. The first one, we're integrating the exponential, so the answer is just going to be itself. On the second one, hopefully you rewrote that x to the power of 4th. Hopefully you brought that up, x to the power of -4, with a power of 2 out front, right? And they don't seem to have that kind of that rewrite. So I'll just show you that rewrite here. 6 to the power of x dx minus 2 times the integral of x to the -4th dx. Oh, they do have that there. Okay. All right, so then we integrate, again, raise the power by 1. This time we're adding 1, right, not subtracting 1. And then you divide by that new power there, okay? So that's going to turn that negative, when you divide by the power of -3, that's going to turn this -2 into a positive. That's how we get the 2/3. Don't forget your plus C. Do not forget your plus C. Okay. Next practice problem. This time we have some trig. Ooh, this one looks fun. Go ahead, pause the video, give this a go, and I'll talk through this one here in a second. All right, hopefully you went ahead and tried this one. This one can be tricky just because of the setup. You're going to have to go ahead and kind of work this one, mold this one to get it to be able to integrate. Notice you have a monomial denominator. When you have one term in the denominator, you can split every single term in the numerator. So I would recommend doing this. 3 over cosine squared x dx plus the integral of cosine squared x over cosine squared of x dx. And if you go ahead and rewrite this, you'll notice that you have 3 over cosine of squared dx. Well, this is the same thing as 3 secant squared x dx plus cosine squared divided by cosine squared is just 1 dx. All right, pause it there. If you got completely stuck, pause me now before I go ahead and show you the answer here in a second. All right, here is the solution. Okay, so there's the rewrite, and if we integrate secant squared, that is tangent of x. Okay, so 3 tan x plus c plus the constant. All right. All right, last example that I have for you, again, gives us an initial value. So kind of dealing with that plus c. What is c? Well, when we have an initial value or a value of a function, an x and a y, we can find that. So here they say if f prime of x is equal to cosecant of x squared, and f of 5 pi over 4 is equal to 3, find f of x. Okay, well, if I want f of x, I'm going to have to go ahead and I'm going to have to integrate f prime of x, right? So f of x is equal to the integral of f prime of x dx. So if I go ahead and integrate this, this is the integral of cosecant x squared dx. And this is equal to, well, I mean, what derivative of what trig function gives us cosecant squared? And that's going to be cotangent, okay? So, and I'm integrating, if I integrate and I get cotangent of x, I'm going to have to add on a negative x, okay? And you can double check that is one of our trig rules, all right? So, here we go. So here is f of x, negative cotangent of x, plus c. All right, I have f of x. How do I find c? Well, what I'm going to have to go ahead and do is I'm going to have to plug in f of 5 pi over 4. And again, this gives us 3. So what I'm going to do is I'm going to say, okay, 3 is equal to negative cotangent of x. Sorry, negative cotangent of 5 pi over 4. Plus c. All I did was plug in the x value that they gave us, right? I plugged in the x value. So there it is. Okay, now all I have to do is go ahead and calculate what is negative cotangent of 5 pi over 4. So cotangent of 5 pi over 4, I don't know what that is, but I do know tangent at 5 pi over 4. So I'll rewrite this using the quotient identity. And then tangent of 5 pi over 4, that's in quadrant 3, that is 1. So negative 1 over 1 plus c is equal to 3. So 3 is equal to negative 1 plus c. Solving for c, we'll go ahead and add 1 to both sides. And we get c is equal to 4. Okay? So since c is equal to 4, again, now I can go ahead and plug that in. So f of x is equal to negative cotangent of x plus c, which is 4. And there's my function. All right, here is a practice problem for you. Go ahead, pause the video, and try this example. All right, this one may have been tricky if you did not see the rewrite. So we have to go ahead and put it in a format to where we can integrate it. 1 over sine of x, tan of x. We can't integrate that right away. But if we use our reciprocal identity rules, 1 over sine x, all right, that is cosecant x, and 1 over tangent x, that is cotangent x dx. And if you integrate that, well, the derivative of cosecant of x gives you negative cosecant cotangent of x. So we don't have that negative, we have to add on the negative, but there is our answer. Negative cosecant of x plus c. All right, that's going to do it for this video. Hopefully you learned how to integrate trig and exponential functions. Give my video a thumbs up, subscribe. I'll catch you next time. Peace out.